right, well, welcome to those who are joining us today for our OSMINE webinar presented by MOVUS. We are going to get started shortly. We'll just give it another couple of minutes and we'll get started right at the top of the hour. Again, thank you to those of you who are joining us. We will be getting started shortly. All right, it looks like we have a few more people joining us. Welcome. We'll be getting started shortly. Okay, looks like it's the top of the hour, so let's go ahead and kick this off. Hello, everyone, and welcome to today's OSMINE webinar presented by MOVUS, who will be sharing their insights into AI-powered machine health for scalable maintenance. My name is Tammy Pisani, and I'm the OSMINE State Manager for Queensland, and I'm delighted to be your host today. Before we begin, I would like to acknowledge that I am hosting this webinar from Brisbane on the traditional lands of the Yagara and Turrbal people. I would also like to acknowledge the traditional custodians of the various lands which we're all working today, and also extend a welcome to Aboriginal and Torres Strait Islander people who may be attending this webinar. So welcome to everyone. From MOVUS, I am joined today by their CEO, Sanjeev Kumar, and Samitha Singhi, who will be speaking on behalf of NISTAR. Together, they will present how operations are evolving from reactive to prescriptive maintenance. They'll share what this looks like in live production, not just in theory, including what has changed on site, how decision-making has become clearer, and what it takes to scale. I should note that this webinar is being recorded and it will be made available to all the attendees and also be available on OSMINE's YouTube channel. During this presentation, you can submit your questions for today's presenters at any time. At the conclusion of their presentation, there'll be a live Q&A. So again, you can submit your questions at any time during the presentation, and we'll be asking our presenters those questions during the Q&A. All right, so with that, I would now like to hand it over to Sanjeev. Sanjeev, the audience is yours.
Thanks, Tammy. Thank you everyone for joining this seminar. My name is Sanjeev. I'm representing MOVUS. Let me straight away go to the point. Many of you would have known about MOVUS because MOVUS is a homegrown Brisbane-based technology company, started many years back. However, last year there was many changes in MOVUS. MOVUS got new capabilities through international alignment with a company called Infinite Uptime, and this is where they got a lot of advanced sensing capability, advanced diagnostic capability. And last year we participated at IMARC, and one of our product got award as the Beacon Breaking Through Innovation product. This is where you can see me collecting the award. What MOVUS does, MOVUS is providing prescriptive AI for plant operations. And the whole purpose of our deliverables as to how can I maximize your throughput and make your plant more efficient. How do we do it? We mostly use advanced sensing and AI analytics. We identify anomalies in advance. We identify early stage fault and provide clearly prescriptive recommendations so that maintenance team can plan corrective actions with high level of confidence. Now, why we are so confident about what we are delivering right now, you can see we have delivered our solution across more than 900 plants globally. And mostly we have deployed our solution across mines and metal, cement and steel plant. And what we observe, wherever we have deployed our solution, we have been able to reduce the unplanned shutdown by over 90%. And not only that, the feedback is the maintenance planning has improved by 20 to 30%. So just to put in the context, if you are in a mines, and then you can see your crushers, conveyors, pump, motors, etc. There's a 10 breakdown, let's say in a year. I, I should be able to bring it to one or less. At the same time, we have observed that not more than 20% of the asset is faulty at any point of time. Due to lack of information about the real-time asset health, when we plan to do maintenance of all the plants. Just to give you a context, we work with one of the mining company around the world. They got coal and iron mining facilities, and we got a feedback that we are monitoring 1,000 assets from those plants. Earlier in their capital shutdown, they used to take 8 days to do a complete maintenance. Now that has been reduced by almost 20-25% because of the availability of real-time health asset of those assets. Just to touch base how the maintenance has evolved over a period of time. Traditionally, we have been in reactive maintenance when we fix when it breaks. The mindset has been always that failure is inevitable, maintenance is a cost center, downtime is accepted. From that era, now we have moved to preventive era, where we can see that OEMs have prescribed us to do a schedule-based maintenance or time-based maintenance. Now, the biggest problem with this is OEM, when they prescribe as a machine is new, but when the machine gets old, the requirement of maintenance schedule also changes. That many a time we don't take that into consideration, and then we lead into either over maintenance or under maintenance. That leads to over spend on the spare part. Couple of years back, many companies mushroomed, including MOVUS and many others, who came up with the predictive maintenance concept, and these companies had sensing capabilities. Many of the company had a platform, but you will see 99% of them have died. They have not been able to successful. At the same time, the adoption at the plant level has not been very good. One of the basic reason is the predictive maintenance create lot many alert. The predictive maintenance will tell you something is going to fail, you need to take action. That created a big time pushback from the users. So let's say a head office decide that I will go in a predictive maintenance solution, condition-based monitoring, I'll deploy sensors, I'll give you a platform. But there are so many alerts that the user said that whether I should focus on the production side or I should focus on alert management. That's the reason predictive maintenance did not succeed. We are one of those 1% company who survived and move beyond predictive maintenance. This is where we came and innovated prescriptive recommendation. That hey, I will not tell you that there is some problem in your machine. I will not give you any alert. I will only give you prescription. So I will identify fault. I will tell you what is the problem. I'll tell you what you need to do in such a way that anybody can execute the task. So this is where we moved in from predictive maintenance to prescriptive, where it's a human in loop system. So instead of going top down, now we are going up bottom up, so that how users can adopt more. Now coming back, what changed in this era when the AI came into the picture, internet came into the picture, IoT sensors become more efficient and effective. The change from the traditional approach to the modern and prescriptive approach. Typically, the alerts which used to come earlier had been converted into recommendation. So number of alerts got drastically reduced. The detection has become more of a diagnostic. So in the traditional approach, you'll have identified that something is wrong in your machine. When you move to the prescriptive, it's more about root cause, not just a symptom. The dashboard has changed to decisions. Typically, a fancy dashboard doesn't help to the plant, but obviously a guided intelligence system is helping the maintenance and the planning and the operation team to take an informed decision. We would have seen that many companies had the centralized monitoring team. So sitting somewhere in the remote, they are observing all the asset and they're guiding the plant team what they need to do. But in our experience, we realize many times there is a clash because the team who's analyzing it and the team who is executing it, there's a gap. So what we have come up in this type of approach, that the right people act at the right point at the need. So the field team get empowered. So each and every recommendations comes in, they go and check whether this is true or false. I just want to bring a case study of a ball mill that many of our people from mines and metals can easily correlate to. This is one of the aluminum smelting plant, and they were working in a traditional maintenance approach. What they realized in a span of 2 years, they had 30 different types of failures, and they lost roughly 176 hours of unplanned downtime in that span of 2 years. Now they deployed our solution. So we moved them from traditional maintenance approach to predictive or prescriptive solutions. And then they realized that next 1.5 years, they just had 5 different types of failures. Out of those 5, you can see one, which is the gearbox failure. They had advance notification 1 month advance. They could not take action on time because the spare part was not available at the site and it took time to come. However, they were well informed that what is going on in the plant and they could adjust their production schedule and manage this catastrophic. Now, my questions or to any of your questions will come that how just by monitoring vibration, temperature, or some parameter, you can address many of the failures like leakage, etc. The same question I asked to this customer, and the response which I got that because you are doing diagnostic early stage fault is identified, fault as simple as structural looseness or base bolt looseness. Now, if you do not take action on this, that creates secondary damage, and those secondary damage, the result of leakage, etc., are the part of those secondary damages. So if you are able to address your initial failure modes, you will not get into the secondary damage, and this is how number of different type of failures can be avoided. So this is where I was telling you that we have been able to reduce by using the AI and advanced analytic and advanced sensing number of breakdowns nearly more than 90%, and so do number of hours of unplanned breakdown. The deliverable approach is pretty simple. It is basically keeping human in loop. It's a closed loop maintenance system which we are using. First is the detect, like AI detect early stage anomalies, and it continuously monitor it that okay, anomaly has come and how it is progressing. Once AI is confident that yes, it should be reported, then it does a diagnose, root cause identified, what is the problem, what is happening, and what user need to be done. The next stage is the recommendations. The clear prescriptive recommendations come to the users who are supposed to do action. Once user act on it, so the platform allow you to plan your maintenance activity, or you can close the system once you act. Once you act, you basically validate whether it was true or false in the system itself. And this validation is a closed loop system. So AI, every time you validate the true or false, the system also learn from your recommendation as well as machine behavior. So from the centralized or I'd say a generic AI, it become more of a agentic, which is learning from your machine itself day in, day out and giving you perfect recommendation. Typically, if you see, you have the first two layer, what you're seeing is your OT layer. The first layer is you have sensors, pumps, motors, gearbox. There are a number of machines in your plant. Above that, you have your OT layer where you have DCS, SCADA, PLC, etc. And on the top two layer, you have the MES, CRM, ERP, etc., and the business enterprise like SAP, Oracle. Where we sit in the middle between OT layer and IT layer, and we ensure that the IT layer is getting the intelligent system from the OT layer, Otherwise, let's say you decide to implement SAP, decide to implement any other maintenance management system, but the data which coming from the data and the intelligence which coming from the OT network, it's not perfect. You will never get the desired output. That's one of the reason what we have observed. Many of the companies who tried systems have not got the desired output. So we are sitting somewhere in the layer 3 in the middle, taking care of the lower layer and ensure that data can easily be integrated with the upper layer. The whole idea of the system is that we should be able to reduce unplanned downtime. We help you optimize your energy consumption, reduce your process deviation, etc. Just to give you a small walkthrough of our platform, what we have done, we have recorded this system, and this is one of the metal plant, where mining and metal plant, where the system is deployed. It will be a little bit fast, but I'll just rush it through. Okay, so you can see this is the corporate dashboard where you can see the visibility, right? You can customize and check how many months data. You can see 146 machines we are monitoring. Out of that, only 18 machines need help. All other machines are running absolutely fine here. So next time when you're planning, you don't have to go all the way to do a maintenance of all 146 plant. Rather, you can just take focus on this 18 asset which is faulty. Oh, sorry. Can you check? It's not moving.
Maybe press the middle of it, the video.
Yeah, okay. Yes. So the next step, you can see when you move from the plant dashboard, corporate dashboard to the plant dashboard, here you know that all the assets which are faulty. You can click and create the report. You can see what is the recommendation which you are supposed to take action on. So you'll have observation, you'll have diagnostic, and then you have a recommendation. Typically, you'll have 2 recommendations to act upon. Yeah, if you can move. You got stuck again, I believe.
You have to press the corner.
Okay. So you can see we got a outcome assistant, which is same as a conversational AI, like a chat GPT. You can ask your question and it will give you whatever reply you want to. If you're taking an action, you can plan the action in the platform itself. Let's say if you have completed the task. Once you completed the task, you can go and close the report in the system. You can tell us whether the report was true or false. You can recognize your saving out of this. You can check your feedback. Let's say if a report is closed, what you have written is mentioned here. You'll have a detailed analysis if you want to check. Now, there's a platform which allow you to do your own analysis if you want to. For example, in this case, you can check a various data and do it. This is about the analytics. We are monitoring 46,000 asset. Last 6 months, we have saved 30,000 hours of unplanned downtime. This is our accuracy. The first one on the left-hand side, what you see is roughly 9% inaccurate. So more than 90% of the time, we are accurate when you're saying there's a problem in your machine, finding the same kind of problem. On the right-hand side, you would have seen which was 0.06% fault, which we have missed. This indicates that more than 99.94% of the asset which we are monitoring, there has not been a failure. So we just wanted to highlight using the AI, utilizing the advanced sensing and the advanced analytics capability, the traditional maintenance management system can be upgraded and downtime can be avoided to a great extent. Now with me today, we're joined by Samitha from Nextstar. She is one of user of our solution. So we thought, why not we take some feedback from the user itself. So Samita, if you are ready, we can ask a couple of questions to you.
Yes, Sanji. Yes, I'm ready.
Great. So Samita, earlier you were using MOVUS solution, which was with machine cloud that we were using, which was mostly of a monitoring solution. And now we have moved you from machine cloud to PlantOS. We would like to talk about your transition to a full diagnostic prescriptive AI platform.
Yes, this is a great move. I hope you can hear me.
You are audible.
Yeah, and the most interesting part for me as an engineer is that um, this plant OS is capturing all three axis data, whereas in machine cloud we got only one single axis worth data. So then or rather diagnosis and the FFT waveforms analysis and the speed detection, everything became more sophisticated and more descriptive, so that we could take a proper decision in troubleshooting the fault.
Great, great. Thanks. Many time when you close the report, you write a time saving, right? You write the time saving that you can see in the platform from closing out report, the number of hours saved. What that meant for your work and the team you work for?
Yes, this has a great effect, particularly when it comes to because now we need to justify the invest, because this is a huge investment, and we need to justify the investment to the top management. Then this information is crucial and critical to record this information correctly in the system. Now we have started to record the saving hours and as well as the diagnostic we detect from the system, as well as from our own analysis. So it's in the progress, and we are confident that it's supporting us to save a great deal of time. Still we are in the early stage, about
Yes,
3-4 months we have
yes.
started to implement this, and we are confident that we can have a great saving in the near future.
Great, great.
Yeah.
So now, because we always talk about when you move from the traditional approach or predictive maintenance solution to prescriptive. So the plant machine cloud was a predictive maintenance platform. Now PlantOS is a prescriptive maintenance platform. We always claim that number of alerts should reduce when you go to prescriptive than predictive. You have used both. So do you see that number of alerts have been reduced drastically? And what is the type of alert you're getting previous to now?
Yes, I can recall one example out of many. We have one exhaust fan where we got about 30 alerts in a week with machine cloud, and now it has been reduced to one single descriptive analytical report on which we acted, and we saved catastrophic failure. And
Great.
we are thankful for MOVUS for being able to saving that equipment.
Thank you. Thank you, Samita, for your wonderful input. And this is what we are aiming for, to provide prescriptive recommendation pinpointed so the maintenance team can focus on various other activities. I think thank you all. I'll be happy to take if there are any questions.
Wonderful. Thank you so much, Sanjeev and Samitha. We really appreciate you both sharing your valuable expertise with us this afternoon. And as Sanjeev mentioned, it's now time for Q&A. So it's not too late to submit your questions for either of our presenters today, which you can do so using the Zoom interface. But I'll kick us off with a couple of questions that we have prepared for y'all. In practice, how is prescriptive maintenance different from predictive maintenance?
So in predictive maintenance, this is what Samita was saying. Earlier, he was getting 30 alerts in a day on a machine
Yes.
on any variation. Because in predictive, we just predict that, okay, I have set all the parameters, you identified it has violated, and you'll get an alert. So now user has to go and check every time. In prescriptive, you will not get alert, you'll get complete diagnostic, what is the problem and what you are supposed to do. Prescriptive has to be a prescribed recommendation, which any user can go and check and correct it.
Very good. Thank you, Sanjeev. And tell me, how does PlantOS fit alongside existing systems like SAP or Maximo? Does it work with it or replace it?
It doesn't replace Maximo or SAP. PlantOS got immense capability. It can work as an independent system. If you have nothing, you don't have anything in your plan, it can plan your maintenance as well. It take data, diagnose, and give you recommendation. It works as a standalone platform. It also got a capability to the same platform can integrate with anybody. We provide data through API, so it can be integrated with SAP Maximo. Let's say if you have SAP APM solution, or if you have a Maximo solution which is creating ticket, the intelligence from the OT layer will come from PlantOS. So PlantOS output can be a great input for the other ERP and maintenance management system.
Great. And then this next question is a great follow-on question. Can organizations use PlantOS without overhauling their existing maintenance systems?
Yes, without touching anything, it can work. If you want to integrate with others, it can seamlessly integrate. If you don't want to integrate, it can work independently. So this is like a fluid. We have designed it in such a way that it doesn't impact any of your existing infrastructure.
Great. Well, thank you. Well, unless there's any other questions from the audience, we'll go ahead and wrap that up. Again, thank you, gentlemen, very much for your time and expertise and sharing it with our audience today. I'd like to give a big thank you to all of you who attended, and thank you for your time and joining us on today's webinar. And just as a reminder, this webinar has been recorded, and a link to the presentation will be sent to all of you and be made available on the OSMINE website. So thank you again to everyone for joining us, and I look forward to welcoming you to another OSMINE webinar in the future. Go out and enjoy your day.
Thank you. Thank you, Tammy. Thank you, Samita. Thank you all.
Thank you very much.